The ISO-STIM-II has 4 modes of operation: timed, gated, direct, and timed direct. In timed mode, the output signal is generated by the built-in timing unit, indicated by the red LED in the center. It is triggered either by a TTL trigger signal at the input connector or with a manual push button. To demonstrate this, we switch the ISO-STIM to timed mode, set the output to voltage, and connect the ISO-mod model cell to the outputs. The timer is set to 1 millisecond and the amplitude to 10 volts. We have an oscilloscope connected to the output of the model cell. In red, we have the input signal, a simple TTL square pulse to trigger the timer. And in blue, there is the output signal, a square pulse with a length of 1 millisecond and an amplitude of 10 volts. Now we change the pulse length of the input signal. As you can see, pulse duration is unaffected by the length of the incoming TTL signal. We can change the length of the output signal with the timer switch. The amplitude changes as we switch at the amplitude switch of the front panel. Now we switch to gated mode. In gated mode, the length of the output signal will be determined by the length of the TTL input signal. This means that the timer is bypassed. Note that the LED is turned off in this mode. Otherwise, this mode behaves like the timed output mode. To demonstrate this, I change the duration of the incoming TTL pulse. The resulting output pulses have the same duration as the input pulses. To demonstrate the unipolar and bipolar output, we switch to timed mode. We set the timer to 1 millisecond and have an output amplitude of 2 volts. In unipolar mode, the ISO-STIM will create a square-shaped signal with the set duration and amplitude, here depicted as A. When set to bipolar mode, a second square-shaped signal will be created with opposite polarity, here depicted as -A. Setting the interface gap will create a short pause between the two pulses A and -A. In direct mode, both the amplitude and the duration, or even the shape of the input signal, is transferred to the output. We demonstrate this here by giving different waveforms to the input. The output signal follows this input, multiplied by the output scaling, in this case 10 volts per volt. We change the input signal from a sine wave to a triangle wave, to a square wave, and back to a sine wave. Now we switch to timed direct mode. This mode is used for pulses of a defined length, but with variable amplitude. We demonstrate this with a sine wave as input signal. Note that there is a certain threshold before the output signal is triggered. By changing the timer, the length of the transferred signal changes accordingly.